Welcome to episode 7 of Generating Conversations. If you are new to our podcast, we are inviting experts in LLM technology from research and industry to talk about big ideas and trends that are shaping the field. In previous episodes, we discussed when it makes sense to build or buy LLM technology, some of the limitations of generative AI, and more recently, where reinforcement learning is headed. Today, I'm really excited to have Shishir Patil and Tianjun Zhang join us to talk about their work on Gorilla. Shishir and Tianjun are nth year PhD students in the Skylab at UC Berkeley, who are both also happen to be my students. Earlier this year, Shishir and Tianjun released the Gorilla model, which is a fine-tuned version of Llama that can auto-generate code snippets using various APIs, like Hugging Face and the Transformers API, as well as Kubernetes. This work has received tons of positive feedback and now has over 500,000 API calls to date. Thank you for joining us, Shishir and Tianjun.
Hello, Joey. Good to be here.
Hi, Joey. Yeah.
Awesome. So maybe can we start with what is Gorilla?
So, Joey, Gorilla is a powerful language model we built for only handling very reliable and accurate API calls. So, unlike general chatbots like ChatGPT and Anthropic's Cloud or other companies building this chatbot, this bot is only used to call APIs and to use external tools and to help you get things done.
Awesome. So there's a lot of big LLM technologies being developed today in the open source and commercial offerings like GPT-4. What differentiates Gorilla from these other efforts?
Yeah, so there's been like a whole cottage industry of open source models that have come out post ChatGPT, mostly to compete with the chatting capability, right? You know, the questions you might want to ask is, I want to travel to Hawaii, what are the kind of things I would do there, so on and so forth, or what's a better school among neighboring schools, which is quite entertaining. But then there's been like a very small but a very focused effort on making these LLMs actually usable for different reasons, right? And you saw some efforts from the financial sector where they came up with their own LLM for intended use case that they might have. And similarly, if you're trying to do like translation or copywriting is one case where people moved away from prompting to actually now even fine-tuning LLMs. Now, Gorilla is in some sense opening up another new domain, which is how do you connect these LLMs to the outside world? So with Gorilla, our hope is that you as a user is going to talk to the LLM, and the LLM is now going to go and read the state of the existing world and then perform some action on the existing world, right? So this is abstract. What do I mean more concretely? As an example is, suppose, Joe, you're teaching a course, spending a whole bunch of time on that. So if you want to know, what is my enrollment on this course, right? Or if a student thinks you, when is our assignments due? And you're like, well, it should be on the course website. So you want to ping the course website. So this includes like pinging the course website, which is reading the status of the world, figuring out, when the assignment is due, and then actually performing an action on the world, which in this case would be sending out an email to the student saying, hey, the first assignment tentatively is on so-and-so date. So scenarios like this, where can you just use the LLM to now read the state of the world and then also bring about some changes in the state.
Right. So in some sense, the way to think about Gorilla is it's being able to invoke other functions, other pieces of code to interact and modify the state of the world, becoming sort of an interface between a human and a wide set of web services and technologies that normally would require a software engineer or a web app to talk to. Now we have Gorilla talking to them directly. It's an exciting direction. Maybe you could give us a little bit of background. Like, how does Gorilla work? Is it a fine-tuning thing? Is it a training thing? How do you build Gorilla?
So yeah, Joey. So Gorilla, we built this. It's both of the fine-tuning and also the concept we developed called retrieval-aware training. Like, what is retrieval-aware training? Let me actually bring this two concepts here, which is one is fine-tuning, one is retriever augmented generation. So this two has been very popular in the current language space. One is for fine-tuning is for actually injecting a little bit of external knowledge or correcting the language model's behavioral questions. Let's say I would be asking a questions and I would want the language model to answer the questions in a specific way without any toxic responses. And the retriever augmented generation, on the other hand, is to just put the text into the prompt without touching any of the model's weights, without any further fine-tuning, training of the model. It would simply says, here's my question, here's my related context for you to answer the questions, and can you actually read to retrieve documentation and answer the question? So these two concepts has been widely adopted in the area language model space on how you can help the model to better tailor to your questions. And what that means in the API domain is like, for the fine-tuning, we can fine-tune the language model as what we fine-tune for other behaviors like generating code, for example, without any external help of the retrieved documentations. But on the other hand, people are also asking or exploring the direction of RAG, which is I provide documentation of the APIs. And then the language model will be able to read from documentation, process its information, and then understand, reason about how to generate the corresponding API calls. So that has been the two things, like in terms of how you can connect LLMs with external API services. And more interestingly, what we are kind of did the comparison, we did some study on fine-tuning versus the concept of retriever-aware training. It's like we adopt both technologies, which means what do we mean by actually we adopt both, right? So we actually provide the documentations of the APIs to the language model, and then we fine-tune the language model to better understand and read the documentations and to generate the reliable and corresponding APIs.
Got it. So maybe to quickly recap, when we think of the creation of the Gorilla model, the training process introduced this retrieval-aware training that allows the model to read documentation more effectively. And then to use Gorilla, when a request comes in, then you retrieve documentation?
Yeah, so it's like, suppose you have the request, I want to generate some image from this textual description, right? Now, the first thing we do is we go through our API documentation database and pick, okay, maybe the Stable Diffusion API is the most relevant API, excuse me. So then it gives us a Gorilla model and says, hey, look, the user would like to generate an image from text. Can you please use the Stable Diffusion API to probably help them come up with a modified, fully formed, fully qualified API that they can use? So it turns out that the retriever did a good job this time and told you to use the Stable Diffusion API. But retrievers are never that accurate, right? And in fact, over here, by accuracy, I mean recall at k, which means if you were to give the retriever k chances, at least once does it get the answer correct. And what we observe is that retrievers are actually not that good, especially when you start increasing the scale, and for tasks that are very similar, right? So in this scenario, the negative case would be, the same prompt wherein you say, I want to generate some image from text, but the retriever said, why don't you use like a Kubernetes API? Now, clearly that in itself cannot help the cause. So you're trying to like teach the LLM this high level bit, where Gorilla is going to implicitly determine, is the retrieved API relevant to the prompt? If so, use it. And if it's not relevant, then Gorilla will discard the retrieved API and just use its pre-trained information and its fine-tuned information to answer the question.
Awesome. So one of the things that I've found really remarkable about the work on Gorilla, and something that I think the audience would enjoy learning more about, is when we started the project, I was convinced that retrieval would be enough. You pull the right documentation, and as you already said, getting the right documentation is a little tricky, but if you get the right documentation, the model will be able to read it and just answer the question. And then you all found something pretty remarkable about the role of fine-tuning. And maybe you could start by like what you found, and what that really means for the kind of future. Is it all retrieval or all fine-tuning, and how will these pieces fit together?
Yeah, Joey, and that's been a top question for many people. And I think at least early evidence for us from Gorilla suggests that fine-tuning is the way to go. Between fine-tuning and retrieval, if you should fine-tune.
Yeah, maybe Tianjun, could you tell me a little bit more?
Yeah, Joey. So here's my opinion on this, on how the retriever versus fine-tuning things. So I think they are, to my opinion, both techniques to injecting some amount of knowledge, or at least correcting, or fine-tuning might do a little bit more. It's like correcting the behavior of the language models. But to my experience, they are both technologies that are injecting some amount of knowledge to the language models. And the hope the very hope for me prior doing the gorilla research is like retriever is enough, as you said. Like we can just prompt language model, writing very careful prompt engineering, and then provide the correct documentation to the language model. And with probably a few shot prompting or chain of thoughts prompting, the language model could magically just figure things out. But it turns out actually it's probably not enough. It works to some extent. Like I would say, to our experience, it's like 50 or 60% each of the times. But if you want to actually really get 90% or 95% of time correctness, maybe the retriever is not enough to get you there. And there is also some of the more recent evidence saying the GPT model can lost in the middle. They only pay attention to the very beginning and the very end documentations and ignore some of the parts. And also the GPT model or the large language models can be really easily distracted by irrelevant text. So which means if your retriever is not good, it retrieves some of the irrelevant text, or if you're not doing very careful enough engineering, the model could be easily distracted. And I think that could be the problem, like fixable by the fine tuning, or in our case, the retriever aware training, which is teaching model, how to kind of extract the real relevant context from the retrieved documentation and try to ignore the other irrelevant parts, or try to pay attention to the only correct documents that are related to your question.
Yeah, that's a good point, Tianjun. Yeah, I guess there's certainly opportunities to use retrieval and fine tuning, and maybe the biggest opportunity for retrieval is around freshness. Do you see a need for that in the design of APIs or of Gorilla?
Yeah, totally, Joey, and that's pretty critical, right? Because how often do you train/fine tune an LLM? Maybe once every 6 months, every month, probably frequently if you can afford it, right? And so and training LLMs, there's a cost aspect to it, but also a second aspect to it, which is how do you know an LLM is good enough to take to prod, right? A lot of classical techniques that people use do not necessarily hold. So all the red teaming techniques and basically evaluating LLMs is hard, which is another reason why you can't just randomly keep fine tuning and deploying these LLMs. So, okay, so LLMs are going to be trained in over small bursts of time, and then it's going to be mature and not touched for some periods of time. But APIs change much more frequently, right? Mature APIs, not so much, but if it's like a recent product, then your APIs may change weekly, if not daily. So in these scenarios, what we find is that using the retriever actually helps with ensuring freshness of data. And that's something we observe, right? Even like in the ML domain, you might have an object detector, maybe you're using a ResNet 18 backbone and determine to upgrade that to a ResNet 101 backbone. Now, in these scenarios, Gorilla is able to actually identify that, look, ResNet 18 to 101 seems like a reasonable upgrade. I've seen that happen in historical APIs, so that makes sense. But if you were to say something like, oh, why to use a ResNet 79 backbone, if that's what your retriever gave you, then Gorilla can actually reason out that, look, this probably does not make sense. So it's not a 1 or 0, it's a confidence distribution, right? So the confidence distribution for Gorilla is going to be like, this seems unlikely, so I'm rather going to ignore this retrieved information and then use my own. So yeah, retrieval, very important for freshness of data, and with our RAT technique, we can actually make it cognizant of what it might expect, what it might not expect as well.
Makes sense. You touched on the costs of fine tuning. As someone who has to fund the fine tuning research, maybe talk us through what does it take to fine tune Gorilla for a new API, like in terms of money. If people are willing to donate resources, please let us know. No kidding. What does it cost to do this work? And maybe also we can talk about the technical expertise afterwards.
Yeah. So I think in general we tried two kind of methods for fine tuning. One is a very popular one called LoRa. It's just low rank. We found that actually, but again, another one is just end-to-end for fine tuning supervised learning. With all the parameters are tunable. So we found actually the latter works a little bit better, but the latter costs a little bit more of the resources, which we fine tune 7 billion and 13 billion of the Llama, actually 8 GPUs of A100, which each one is 80 gigabytes. But the fine tuning process only costs, I think, a couple hours, less than 10 hours. So it should be a fairly not time-consuming, but GPU-consuming pipeline.
So if your advisor were hypothetically paying for this, which he is, and it were, it's 8 GPUs for 10 hours, what does that look like? How much money is that going to cost?
It's about 30K USD a month, roughly. So 10 hours would be about not too much money.
Okay.
We can afford it.
Let's say under 1,000?
Yeah, under 1,000. So it also depends on the models. Like Llama models tend to converge quickly. They also have a lot of systems optimizations going that way. If you want like an Apache 2.0 license models like NPT or Falcon, they take slightly longer, up to a day even, because they don't have A, it takes more epochs to converge, and B, they don't have all the systems optimizations going for them. So.
All right, so it's not too expensive, but it also takes some expertise. What is the expertise required? Can you just plug and go? Did you have to tune anything? Yeah, talk through the process.
Yeah, so the expertise lies in the whole recipe, right? And one thing that benefits us is getting data. It's not legally hard because unlike content that might be contested, APIs is people like to distribute APIs. So like the more APIs you use for say Stripe makes more money. So it's in their best interest. So you get a lot of APIs, but it's in multiple different documentations, right? Like Hugging Face, TensorFlow have model cards. Some of them have Open API spec. Some, Kubernetes has Swagger files, etc. So you have data that's spread across multiple different modalities. First thing you want to do is take that and parse that into very compact representation. We used JSON, but then JSON was not very robust, especially when you start having rich text. So then we had to move away to use markers. And this is A, to deal with the token size, and B, to have a compact representation that's also easy for the retriever and database. And then we use this popular technique called self-instruct, where you're trying to give it the data and then generate the label, to put it succinctly. And so you're trying to say, hey, look, I have these APIs. Can you please try to think about ways how people might actually invoke this, right? So this is a slightly easier task. You only need general capabilities. So you can use any off-the-shelf commercial models to now generate self-instruct data set. And once you have this, then you're trying to now mesh everything together and then use RAT that Tianjun just discussed, and then train the end-to-end model. So this is roughly the fine-tuning recipe.
Got it. And then, so yeah, the getting the data seems to actually be perhaps the harder part of the fine-tuning process, and preparing it in a good form that, in the right form to get good results for fine-tuning. Okay. So you did this for a bunch of APIs. What APIs does Gorilla support now?
Yeah, so we start off, so Joey, much to your delight, we started off wanting to write a paper and for the ML community. So a lot of APIs we looked at was Hugging Face, TensorFlow, Torch Hub, because this was within the community, people use it. There's more relevance. But then once we released the model, we had a Discord server, so we got a lot of feedback, and we realized that ML practitioners know exactly what APIs they want to use. They're not the ones searching for APIs. But then we got a lot of feedback from developers saying, hey, look, I tend to use Kubernetes on the daily, but I just don't seem to remember APIs because there is so many of them and it's so hard. So then we collected a bunch of feedback. And so right now we support, other than the three that I already mentioned in the ML domain, Kubernetes, GCP, AWS, basically Azure and all the other hyperscalers, infrastructure providers, and also SED, awk, and all the other whole bevy of Linux commands that people do use on their command lines. So right now this is, and it's growing. Not only is it growing, we also accept APIs from users, and a lot of people can contribute their API into APIs too. So if you have any APIs to all the listeners, if you're willing to contribute, then we can train the model, and then all of the users who are using Gorilla can now access your services through the APIs that you would enable.
Cool. So it sounds like there are a lot of ways that, a lot of APIs that you support. How does a user use Gorilla today?
So we mainly support two variants of the interface for the users. One is the chat completion API, which is very similar to the OpenAI chat completion APIs. And you just drop in a place, replace the OpenAI endpoint with our Gorilla endpoint, which we hosted for you. And then you get the answer for your chat completion, which is consists of some of the model names, API calls, and arguments, also some of the explanation on how to use APIs. And another interface we provide more specifically, or maybe tailor a little bit more to the developers, is this command line interface, which you can just do very easily pip install Gorilla-CLI, and then you can ask the model the question of any command line interface or any command line API that you want to use, like what we have been talked about, the GitHub, Conda, Kubernetes, also some of the cloud support.
Can you give us an example of how you'd use the command line interface?
Okay, so Tianjun just mentioned about the command line, right? So here's an example where you do pip install Gorilla CLI, and this would install the CLI for you. And when you want to start using it, all you have to do is use the magic word Gorilla. And a popular request could be, oh, list all my GCP instances, say. And then what Gorilla will do is actually go ahead, hit our API endpoints, and then shows you multiple options, right? This is to give control to the user, where you can see the different options that we generate, and then pick the one that you like. And it's only after you hit the return key, so go ahead, execute the command, and then show that we have instances. And Joey, you will be delighted to learn that a lot of them are terminated, so it's not billing you anything.
Yes, for our audience, the Gorilla project has been quite expensive to run, in part because we are now serving the Gorilla system and running multiple models. And you see multiple options because we collect data on what options perform better so we can improve the model in the future. Very cool. Again, check out the Gorilla project. The command line makes it pretty easy for people to try. Maybe I'll ask the kind of a concluding thought. Where is this whole project going? What's next for Gorilla?
So we have been, actually, as we have discussed at the very beginning, this is also some similar to the lost in the middle, and we highlight the thoughts at the beginning and the end. It's like we view these LLMs today as a great chatbot, but tomorrow maybe it's an interface that between the users and the entire world. Either it's might be a physical world, for example, it can control the robots as some of the Google's research has been heading towards, or it can control some of the software through our API calls. So what we have been imagining is like the world which the user sits at the interface of the Gorilla, and Gorilla go and connect with the entire world physically and virtually, and also get some things executed and directly return back the results for the users.
And this opens up many research questions, right? One example is, okay, how do you make your retrievers better? And there's been a lot of talk today on how do you augment your LLMs with retrievers, especially here hallucination is important. So you can't call an API that does not exist. So how do you make that better? And second is, okay, what you're calling an API, what happens if the API fails, right? If it's like a Stripe API, if it fails, you can't try it twice because it then double charging the user. So that's a bad idea. Well, then, what do you do? It depends on the API. If it's like trying to download something, then maybe try again. Or do you use a different mirror, right? So when things break, I think this is when it gets really interesting, at least from a research perspective. And obviously, there's this question of, can I compose API calls together, right? And, if it's command line, we know how to do that, but can I compose API calls? Well, one is like a GraphQL query, then I want to run a JavaScript API, then I want to top it off with a RESTful API call. So then how do I compose and chain these API calls together to get a user to do what they want? So a lot of interesting research directions to pursue. Yeah.
Awesome. So maybe we'll end with one more question. So I'm hoping that people are excited to try out Gorilla and maybe even participate in the research. How should people get involved?
Yeah, so Gorilla has been open sourced and everything is Apache 2.0. So if you're an enterprise or if you want to use it commercially, you should feel free to try it out. All of our data sets and models are completely open sourced and available. So we, as Tianjun mentioned, we have hosted endpoints where you can hit Gorilla with your chat completion request. Should be pretty straightforward. If it's not, raise a GitHub issue and we will fix it for you. But otherwise, GitHub Gorilla is one place where the community is. It's pretty active. We also have a Discord server where we're discussing, potential next steps, and there's also like a support channel. So if you have any questions or suggestions, even these are good modalities to discuss.
All right. Thank you for joining us. And hopefully we'll have a chance to use Gorilla more in the future.
Thank you, Joey.
Thanks,
It's
Joey.
fun being interviewed by an advisor 4 years after he interviewed you for your PhD admission.
Yes. Yes. And soon to graduate, hopefully, too. On the way. All right. Thank you all. Bye.